Hi everyone. In this video, we'll go through 5 marker problems related to multiple and submultiple angles. Here is a list of trigonometric ratios for multiple angles. Sin 2a, cos 2a, tan 2a. Now using these formulas, we'll solve the 5 marker problems. Now let's solve this 5 marker problem where we have to prove that 1 plus cos 2a plus sin 2a by 1 minus cos 2a plus sin 2a is cot a. Now we'll start with LHS. This entire portion is LHS and this is RHS, which is cot a. So LHS, we'll put LHS here first, right? And now we need cos 2a and sin 2a formulas because we will have to substitute cos 2a and sin 2a formulas here. Cos 2a is, there are multiple formulas for cos 2a. We will use 2 cos square a minus 1. And for sin 2a, it is 2 sin a cos a. We'll use these formulas. So we get 1 plus cos 2a is 2 cos square a minus 1 plus sin 2a is 2 sin a into cos a. Similarly, in the denominator, we have 1 minus cos 2a, which is, we'll use the same formula, 2 cos square a minus 1 plus sin 2a is 2 sin a into cos a. So we have substituted this. Now, 1 and minus 1 will get cancelled. So if you notice, 2 cos a is common here, right? We'll take 2 cos a as common factor. We'll get 2 cos a plus sin a. Now let's expand this. The denominator will get 2 cos square a minus and minuses plus 1 plus 2 sin a into cos a. So we'll get 1 plus 1 is 2. And let's copy the rest. Let's take 2 as common, right? In the denominator, we'll get, if we take 2 as common, we'll get 1 minus cos square a plus sin a into cos a. Right? We can cancel this 2 and this 2. Now what do we do with 1, right? We can write 1 as cos square a plus sin square a is equal to 1, right? We can use this particular trigonometric formula and put it here. So we'll get, so instead of 1, I'll put cos square a plus sin square a. And then I'll copy the rest, which is minus cos square a plus sin a into cos a. Minus cos square a and cos square a will get cancelled. We are left with these two terms. Now again, we can take sin a as common between these two. So if I take sin a as common, I'll get sin a plus cos a. Now you will see that both these terms will get cancelled. So we are left with, this 2 shouldn't be here. We cancelled it here. So we are left with cos a by sin a. What is cos a by sin a? It is cot a, which is equal to RHS. So we have proven this particular expression. One more thing, right? We used cos 2a formula as 2 cos square a minus 1, right? In both the places here also we used 2 cos square a minus 1. The denominator also we used 2 cos square a minus 1. Another method is, in the denominator you can use cos 2a is equal to 1 minus 2 sin square a. We can use this formula in the denominator. Then also you'll get the same answer, but the steps will be slightly different, right? You can try this out, but you will surely get the answer. You can use 1 minus 2 sin square a here, right? Here you can use 1 minus 2 sin square a and you can substitute and try out. Now let's solve this problem where we have to prove that cos 3a by 2 cos 2a minus 1 is cos a, right? Again, let's start with LHS, right? This entire thing is LHS and cos a is RHS. Now, what is cos 3a formula? Let's substitute cos 3a formula. Cos 3a is 4 cos cube a minus 3 cos a. So let's substitute 4 cos cube a minus 3 cos a. And 2 cos 2a. What is cos 2a? Again, 2 cos square a minus 1. So 2 cos square a minus 1 and this minus 1 here. So let's simplify. We'll get two into 2 will be 4 cos square a minus 2 minus 1. This is nothing but 4 cos cube a minus 3 cos a by 4 cos square a minus 3. Now we can take cos common, right, in the numerator, because cos is here. In both the terms we have cos. We can take cos as common factor. So if you take cos as common factor, we'll get 4 cos square a minus 3. right? And now in the denominator, we'll just copy this. Now you notice this and this is same. So we can cancel. We can cancel this term and this term. And we are left with cos A, which is nothing but equal to RHS. So we have proved this particular expression. Now we'll have to find cos 15. This is second part of the problem. So what is cos 15? So here for this entire expression, we got cos A as the answer. Now instead of A, we'll substitute 15. Instead of A, we'll put 15. So cos 15. Now what we will do, wherever there is A, we'll put 15, right? We will substitute. So let's substitute this. So cos 3 into 15 by 2 cos 2 into A, that is 15 minus 1. So we'll get cos 45 by 2 cos 15 into 2 is 30 minus 1. What is cos 45? Cos 45 is 1 by root 2. And what is cos 30? Cos 30 is root 3 by 2. So if you simplify this, you'll get 1 by root 2 by 2 and 2 will get cancelled. So we'll be left with root 3 minus 1. So here we have to assume that this is divided by 1. We have to assume. And then we take it on top. It will become a reciprocal. We'll get 1 by root 2 into, it will become reciprocal 1 by root 3 minus 1, which is nothing but 1 by root 2 into root 3 minus 1. So this is the value for cos 15. Now let's take another example where we have to prove that cos to the power 6a plus sin to the power 6a is equal to 1 minus 3 by 4 sine square of 2a. Now what do we do? So let's take the LHS first. LHS is cos to the power 6a plus sine to the power 6a. Now what we will do is, we will write this as cos square of a, the whole cube, plus sine square of a, the whole cube. So we can write the 6 in this form because 2 into 3 is 6. 2 into 3 is 6. So we'll split it up, right? We'll split it up. The reason we split it up is because it's easy for us when there is cos square and sine square. It's easy. So we are going to put cos square inside square and put 3 outside. There is one algebraic formula which is a plus b the whole cube is a cube plus b cube plus 3a square b plus 3ab square. So this is the formula, algebraic formula. Now if you notice, this is like a cube and this is like b cube. A is cos a and b is sin a, right? So we need to find out a cube plus b cube. What is a cube plus b cube? We know a plus b the whole cube formula. This is the a plus b the whole cube formula. This is basically nothing but a plus b into a plus b into a plus b. So when you multiply all these three terms, you will get this as the answer. Now, how do we find a cube plus b cube? Because we need to substitute a cube plus b cube here. So a cube plus b cube would be, let us shift this entire thing to this side, right? Let us shift it this side. So we'll get a plus b the whole cube. When this goes the other side, it will become minus 3a square. And this one also comes to the other side, it will become minus 3ab square. Now instead of a, we have cos square a. Instead of b, we have sine square a. Now let's substitute these values in this entire expression. LHS is cos square a to the power 3 plus sine square a to the power 3. Now I'll substitute as per this formula. So it's going to be a cube plus b cube, right? This is of the form a cube plus b cube. I'll use this formula. A cube plus b cube, a cube plus b cube, a cube plus b cube. I'll write a plus b the whole cube, a plus b the whole cube, that is cos square a plus sine square a the whole cube. That is, instead of a, we have cos square a, instead of b, we have sine square a. So we are adding both and we have to the power 3 here. Then minus 3. What instead of a, what do we have? Instead of a, we have cos square a. Cos square a, and we have again the square. And instead of b, we have sine square a. Then we have minus 3ab square. 3. Instead of a, we have cos square a. Instead of b, we have sine square a. and there is already a square here. So the whole square. Cos square a plus sin square a is 1, right? Cos square a plus sin square a, this entire thing is 1, correct? So let's put this 1 minus. Now if you notice, cos square a and sin square a is common. 3 cos square a, sin square a, all this is common. So let's take the common factor out. So it will be 3 cos square a and sin square a. So 1 cos square a is outside. So we are left with another cos square a, right? Because you have to the power 2 here. Minus, again, 1 sin square a is outside and we are left with another sin square a. Right? We have taken minus outside. So we have taken minus also as common factor. So what will happen? Minus here will become plus, minus here will become plus. The signs will get reversed when you take minus outside. Signs inside will get reversed. It was minus cos square a, it will become plus. It was again, here also it was minus, it will become plus. Now, again, cos square a plus sin square a is 1. So we can substitute here. 1 minus 3 cos square a into sin square a into 1. This is nothing but 1 minus 3 cos square a into sin square a. Now what do we do? How do we proceed from here? Let's look at the RHS. Let's look at the RHS. This is the RHS. Here if you notice there is 2a. This is the clue. This is the clue. You have 2a, sin 2a, which means in this expression we should get sin 2a. How do we get sin 2a? Now let's remember the formula for sin 2a. Sin 2a is 2 sin a into cos a. This is the formula, multiple angle formula for sin 2a. So what I can do here is I can split this, right? 3 cos a into sin a into cos a into sin a. Let me split this, right? I have split this cos a 2 times and sin a 2 times. So now I have cos a sin a, I have cos a sin a, which is what is there in sin 2a, right? Now I have sin a cos a here. I have sin a cos a here. If I shift this 2 here, what will happen? It will be sin 2a by 2, correct? This is multiplication. If I shift, it's going to become division. Sin 2a by 2 is sin a by cos a. Sin 2a by 2 is sin a by cos a. So what we will do is 1 minus 3. Instead of cos a sin a, we'll write sin 2a by 2. Sin 2a by 2. Again, same thing. Cos a sin a is sin 2a by 2. This is nothing but 1 minus 3. I'll multiply 2 into 2 is 4. Sin 2a into sin 2a is sin square 2a. Now, did we get the RHS? Let's check out. 1 minus 3 by 4 sin square 2a. 1 minus 3 by 4 sin square 2a. So, we've got the RHS. Hence, we have proven that LHS is equal to RHS. We have proven that this particular expression is true. See, at this point, we got stuck. At this point, we will not know what needs to be done, right? That is when we will have to look at the RHS, right? We'll have to look at the RHS. This 2a, sin 2a is the clue, right? Now, we know sin 2a is 2 sin a cos a, which means we have sin a cos a here. We just don't have 2. So, what we can do, what is sin a cos a from this formula? Sin a cos a is, you take 2 to the other side, it will become sin 2a by 2. That's all. You substitute it and we get the RHS. Now, we'll take another problem where we have to prove that secant 45 plus a into secant 45 minus a is 2 secant 2a. Now, let's take the LHS first. LHS is secant 45 plus a into secant 45 minus a. And this is the RHS, right? We have to prove this. So, what is secant 45 plus a? So, we don't know what is secant values, right? These are compound angle values. These are compound angles, right? Addition of 2 angles, subtraction of 2 angles, these are compound angles. But we don't know secant form, right? We know just cos, sin and tan. So, what is secant? What is secant? 1 by cos is secant, correct? 1 by cos theta is secant theta. Now, what we'll do, instead of secant theta, we'll put 1 by cos theta. That is, I'll write this as 1 by cos 45 plus a. Similarly, here also I'll write 1 by cos of 45 minus a. Now we will use simple. We'll use cos a plus b formula, right? What is cos a plus b? Simple. Cos a into cos b minus sin a into sin b. Cos formula is very easy. Cos is on one side, sin is on the other side, and with the opposite side. here it is plus, so here we'll have minus. Here it is plus, so here we'll have minus. Now let's substitute. 1 by cos 45 plus a is cos 45 into cos a minus sin 45 into sin a into same thing, same formula we'll use, but there is negative sign here. So it will be cos 45 into cos a, it will be plus this time. There is minus, so it's going to be plus. Here it was plus, so we have minus. And sin 45 into sin a. So we have done the substitutions. Now we'll see cos 45 is 1 by root 2. Remember, cos 45 is 1 by root 2. Then we have cos a. Sin 45 is also 1 by root 2. Sin 45 is also 1 by root 2. And sin a into 1 by cos 45 is 1 by root 2 into cos a plus sin 45 is 1 by root 2 into sin a. So we'll rewrite this neatly. 1 into 1 is 1, right? We'll put this. So we'll take 1 by root 2 as common here, right? Here also there is 1 by root 2 common, here also. So we'll get cos a minus sin a into, here also we'll take 1 by root 2 as common. Here also there is common. We'll get cos a plus sin a. Now we'll multiply 1 by root 2 into 1 by root 2 is 1 by root 2 the whole square, which is half. So we'll get 1 by half into cos a minus sin a into cos a plus sin a. Now if you carefully notice this, in algebra we have this form a plus b into a minus b is equal to a square minus b square. Now if you notice this expression, cos a is like a, sin a is like b, we have a minus b, again cos a is a, sin a is b, and a plus b. So we have a minus b and a plus b combination. If you notice here, this is of the form a minus b into a plus b. This should be equal to a square minus b square. Now what we will do, 1 by 1 by 2 is, we can push 2 on top. So it will become 2 by 1. 2 by 1 into, we can write this as a square minus b square. Instead of a, we have cos a, cos square a. Instead of b, we have sin a, which is sin square a minus, right, a square minus b square. So cos square a minus sin square a. Again, if you notice this formula, one of the cos 2a formulas is cos square a minus sin square a. Cos square a minus sin square is cos 2a. So we'll substitute. This is going to be 1 by cos 2a. What is 1 by cos? 1 by cos is secant. So it will be 2 into secant 2a. This is equal to RHS. So we have proven this particular expression. We've got the RHS, which is 2 secant 2a. RHS is 2 secant 2a. With this, we have come to the end of this particular topic. If you have found the video useful, do like it and share it.